Now let's take two examples. So suppose there are students and their marks that they got in one of the test marks out of 100, let's say, student A, student B, student C, student D. Suppose the marks was 76, 81, 95, 98, and suppose 80. Suppose the student A got 81 marks in test 1, B got 76 marks, C got 95, and also D obtained 95. Okay. Here you can see that this correspondence is a function. Why? Let's take it. Let's think in a practical way. Okay. So our student can get 81 marks in an exam. That's fine. It's possible. B got 76. It's also fine. C and D both got 95. Is this true? Of course, it is true that two students may get same marks. Okay. So this is a function, right? It satisfies the definition of function. Now let's suppose this is example number 1, and let's take another example, which is example number 2, and the example is similar. Students, marks. Suppose A got 95, B got 79, D got 83, and B got 91, and C got 95. A got 95. Well, a student can get 95. That's possible. C got 95. That's also possible. Two students can get the same marks. D got 83. That's possible. But how about B? B got 79 and B got 91. Is this possible? Is it possible that a student can get two different marks in the same test for the same subject? It's not possible. So this is not a function. This example is an example of function, but this example is not an example of function. Okay. Why this is not an example of function? It satisfies the first condition that each and every element of the domain has a correspondence in the range, but the correspondence for this element is not unique. So that's why this is not a function. However, this is a function. Okay. So that's one way how to understand functions, how to figure out whether a correspondence is a function or not. Okay. Let's try to see whether graph of an equation is a function or not. Let's consider graphs of few equations. Let's take these 4 examples. The first one is a straight line which passes through the origin. Y equals to x is its equation. Another is the circle. Its radius is r square and it lies in the center. The third one is the quadratic equation, y equals to x plus 2 whole square. If we think this is 2. And the fourth one is y equals to. The fourth one is y square equals to x. To see whether these equations represent a function or not, we go for the vertical line test. The vertical line test says that if graph of an equation is given, then we draw many vertical lines along the graph of the equation, and If the graph intersects one vertical line at one and only one point, then it's a function. If the vertical line touches or intersects the graph in more than one point, then it is not a function. Okay. Let's draw many vertical lines along it. Okay. So the first vertical line touches exactly at one point. So no matter how many vertical lines you draw, the line y equals to x intersects them at one and only one point. So this is a function. Let's draw many vertical lines, okay, which intersects the circle. Then you can see that this vertical line touches the circle at 2 points. The y-axis also touches the circle at 2 points, and another vertical line also touches at 2 points. So this is not a function. How about the third one? This is one, it intersects at only one point. Another, this also intersects at only one point. Another vertical line also intersects only at one point. So this is a function. Let's draw several vertical lines. Then you can clearly see that the vertical lines intersect at 2 points. So this is not a function. Not a function. Okay. So this is the way how we determine whether it is function or not. Okay, here's the question. But how do you correspond the vertical line test with the definition of the function? Comment below. Thank you.